this room will get there if you're lucky, right? You know, as long as you don't do something silly on your motorbike or get some disease or something, you'll get the feeling what I'm talking about. And you'll remember that there. It's not a bad feeling. I mean, truthfully, I'm very happy to have grandkids and young children. But that's what. Okay, where we were at last time is we're in this chapter, and again, this is. Let me get back to where we were at. I was reading ahead and making sure I knew where we were going. And the last discussion, we were getting ready to talk about control. They got all these slides, control structures, control structures. Here we go. Control structures are, and again, I know that this pen won't work here. No, it doesn't work. But a control structure is a way to move the control of the program to someplace else in your program. Going back to, the easiest way is, why don't you unlock this door here? Why don't you just go ahead and unlock this door here? That way, nobody has to listen to that beep beep. Just unlock that one. That way, if anybody's showing up late, which we know that a few people will, right? Okay, going back to my story of the young ladies baking a cake, right? That there. Yeah, I mean, and they must eat a lot of cake the way that I talked about. Actually, cakes aren't real popular in Malaysia as a general rule. I use that because, in the U.S. we bake cookies and we bake cakes. Biscuits and cakes aren't quite as popular for desserts. But as I said, I'm an old person. I'll stick with the stories I know out there. But if you're baking your cake and you open up your cabinet and you see you have no flour, right? You have two choices. Well, one is you started making the cake. You've got your wet ingredients already mixed in on the countertop. So you will stop and go to the store and buy flour. Right there. Same thing, the guys are, they're repairing your motorbike and you realize that a part is Rozak, it's broken. You go to the motorcycle shop and you buy a new spark plug or muffler or whatever, starter or whatever is defective in your car, right? Well, that's a control structure. You stop what you're doing for some reason and you do something else. But when you get done with that, you come back to where you were at, right there. And we could not have programming if we didn't have control where we can change directions. That there. If we can only do one set of directions in a straight line and never make decisions or do something different, our programs would be fairly boring. Right there. That there. So we have to transfer control of our software. Normal program is called sequential execution. It goes one line to the next, one line to the next, one line to the next. Microprocessors were designed that way since the 1970s, late 1960s. Intel came up with the first microprocessor, the 4004, and introduced the concept of sequential programming right there. Actually, it existed before the microprocessor. But the whole idea is we do one line at a time in our code, and sometimes we have to change directions. Now, we used to have a statement called the go-to, and I know I talked about this before, that allows us to just arbitrarily change directions. The go-to resulted in a lot of what they called spaghetti code, and I guess you would call it me soup here. That there. But when you look at a bowl of spaghetti or a bowl of me soup, what you find is everything is tangled into a mess, right? You can't follow one strand to the other. It's very difficult to follow the flow of your program with these go-tos, because I go down a certain point, and then I jump off, I do something else, then I have another go-to, I go someplace else, and you end up with what we used to refer to as spaghetti code. And again, I'm going to call it me soup code here, that there, because it's, spaghetti's not popular in Malaysia, right? But you eat a lot of me soup, that there. One of my favorite restaurants was at Me Tarik. It's a Chinese out there at Edelman. But regardless, when they did away with the go-to statement, and it still exists, it's still there, we just don't show you how to use it. As programming instructors, we just kind of said, we're not going to use it. It creates bad habits that they're, it's kind of like teaching people how to run red lights. Some people will still figure out that when the light is red, if there's no cars coming, they can go ahead and move through the red light, right? Unfortunately, I saw two motorbikes just last week that tried to do it at the same time and met in the middle. And when motorbikes meet in the middle of an intersection, both trying to run the red light as fast as they can, usually bad things happen, right? And that's what happens with spaghetti code right there. So the finger of the blame is pointed to that there. There's lots of reasons why there's bad code out there. When I say bad code, hard to read, hard to follow, hard to debug, has all kinds of problems right there. So, but the idea of structured programming came around about the time I started learning how to program right there. So I was taught a lot of bad habits. I was taught the go-to statement right there. So, but the researchers demonstrated that programs could be written without any go-tos. Hence, we don't have the go-to statement in our textbook anymore. It's gone. That's there. And usually go-tos mean, you just have another place in your program. You just simply say go-to. Now, in terms of real life, we have the equivalent of the go-to is let's go to grandma's house for dinner. But in reality, that's not a go-to because you're going to grandma's house for dinner, but then you're returning back home, right? So it's more like a call to a subroutine, which we'll cover later, or a function call right there. It's not a arbitrary. Now, sometimes in life we have go-tos. You go off to college, and then it's usually followed is you go find a job, then you go find a spouse, then you go find a house, and then you go have children. I mean, life has a progression of go-tos, but those are normal progressions in life. That's there, and they shouldn't be arbitrary. Now, you might say my life has been somewhat arbitrary because I've lived in 3 different continents and had multiple things, but generally we try to structure even our daily lives to where there's some semblance of a plan right there. So this whole section talks about results were impressive, so reduced development times. So when we got rid of the go-tos, we got to the point where we didn't need to debug spaghetti code anymore. We tried to get rid of the me soup type of code that just kind of went wherever it wanted to go and did whatever. And a lot of the early languages kind of forced the go-tos right there, especially the early assembly languages right there. So the flow chart was introduced right there. This book will refer to flow charts. I talked briefly about this last hour, or last discussion. A flow chart is a graphical representation of how our program is going to work. I personally have not drawn a flow chart in probably 20 years. That tells you that there. I know a lot of programming instructors, especially in computer science, where people are majoring in writing software. You're not computer science majors, you're engineering majors. So your major emphasis in your study is machines and power distribution and fuses and the wiring of buildings and things like that. And you may just program occasionally out there. Although I say that with a little bit apprehensive because I know a lot of people went through school, especially back in my day, with no intention of writing software for a living and ended up writing software for a living. Some of you in this room, I hate to tell you this, are going to become programmers at some point in your career. You may not like it at first. Some of you may love it, but some of you will become programmers out there. And that goes back to something that I was taught many years ago by a manager I worked for. And it was on a contracting job. And I asked him why he hired me for the job instead of a computer programmer. And he said it was a lot easier to teach an engineer how to program than it is to teach a programmer how to be an engineer. Right there. Engineers tend to be more versatile than programmers. Right there. Although you hear the term computer engineer or software engineer, they're not really engineers because as soon as they get into the hardware side of things, they tend to fall apart right there. And as a electrical engineer, you've had courses in microprocessors, you've had courses in power distribution, you've had courses in wiring, you've had courses in electronics. So as a result, you know hardware. So writing software to control the hardware is easier for somebody who understands the hardware than to try to take a software engineer who does nothing but write desktop applications and try to teach him how to control a robot, or how to teach him or her how to program an assembly line, or come up with the algorithms for an electric car that has to have sensors that interface and all kinds of hardware things right there. So that's the result. So some of you will end up doing that there. Flowcharts are useful for developing, presenting out there. The only time I've really seen flowcharts, and I said I have not done anything in 20 years, but I've been teaching for over 30 years. So it's been over 20 years since I've worked as a full-time industry person. Now, I've done a lot of summer gigs where I've worked for companies. I've done a lot of project gigs that there. I've actually done 1 or 2 project gigs since I've been in Malaysia, where I've worked on small projects out there. So, which, at some point I'll probably retire, just do the small programming or the design gigs that there. But most of the time when I've seen flowcharts in the last 20 years has really been in presentations. Where somebody in a design review is trying to outline the flow of the software or the project, how it's going to work. They actually don't use it to write the code, but they use it to convince other people that this is the way we should write our code. I'm sure the boys at Google and the gals at Google, although Google doesn't hire enough women from what I understand, that's been one of their major lawsuits against them right there. But the guys and gals at Microsoft and Yahoo, of course, I know it does because their CEO is a woman. But regardless, these people write a lot of very high-level code to do a lot of very interesting things. And they're not hardware engineers per se, although Amazon's got a lot of hardware engineers, because actually Amazon's probably the largest cloud storage company, so they have a lot of hardware. But a lot of these companies like Google, they have computers, but they don't design them out there. But they will do flow charts to kind of outline the top level how things are working once it gets down to the individual programmers, they tend to jump into pseudocode. I almost always jump into pseudocode if the project's small enough. The larger the project, the greater the need for flowcharts. So if I'm going to design Windows 12 or Android 9, Android 8 is supposed to be coming out, I would probably start with some flowcharts right there of how things are going to work. So this kind of gets into square boxes. There's just simply sequential statements. Rounded that there begin, there are comments, ends right there. This gets into all kinds of selections. But the most important one that we're talking about now is the decision making. So we have three types of decision making structures that are covered in this chapter. There's actually more. We've already talked about the if statement, right? Now, another one that is just as interesting is the if else. Now, you'll hear me use the term if then else, and that's because I'm old and antiquated, and BASIC use the phrase if condition then, whatever you wanted to do, followed by else out there. So in BASIC, it was an if then else. In Fortran, it was an if then else. In C, it's just simply if else right there. And then the last one that this chapter talks about is the switch statement. So I'm going to go through these three statements today. What you probably will find is you'll probably find an assignment popping up in the next couple of days, and to make up for my, lay in bed and get some rest day. That there, just because I'm gonna get some rest doesn't mean I'm gonna let you get some rest, right there. So I'll probably give you an assignment out of chapter 3. I was actually looking at them. Right, as you can see, I was actually looking at them beforehand. So, I'm looking at probably 3.45 is probably the one I'm going to give you. And that involves doing some looping out there. So I'll wait for that to show up on both Facebook and VLE, but there'll be an assignment that'll follow up. Yeah, the assignment is basically a computer program. You'll write a program, and then you'll just submit your program along with a screenshot of it running there through the VLE. And you'll usually get full marks or 0 marks. So I got scolded last time from Tyrell because I didn't sit down and differentiate. But typically these kinds of programs, and I try to explain, is you get them to work or you don't get them to work. There's usually one way of doing them, and then so it's kind of a binary grading scale. You get them done. Okay, these are the three types right there. We've already covered one, but we're going to look at it again. Then we're going to cover the if else right there, and then the switch right there. And we'll probably get through that there. The if statement is a single selection. If a condition is true, we do something right there. If no milk in the refrigerator, that's our condition. If milk equals 0, in other words, we have no milk in the refrigerator, we do something. We go to the store and we buy milk, right? Out there. So the if else is a double selection. If we have milk, we use milk. But if we don't have milk, maybe we'll use coconut milk instead. Or maybe we'll use cream instead. Right there. So you have a choice of two different things. If a student's grade is greater than 60 using the U.S. scale, which gets me in trouble here, because I tend to still use the U.S. scale, which gives too high a grades under the Malaysian scale. That's why I get scolded a lot, because I give mostly A's and B's, because I still look at anything below a 60 as a failing. And I think here it's anything below a 40 is a failing. Is that right? Correct? So I almost never fail anybody because I'm thinking in my mind that the student who's getting a 50 is failing the course. In reality, he's getting a D or a C, right? Out there. So, yeah, students don't complain about the fact I give too high of grades, but the administration does. But I don't care about administrators. I was an administrator for a number of years, and I didn't care for myself as an administrator. University administration is the worst job on the planet. That there. So, that there. But we have the if else. That there. If a condition is true, we do one thing. If it's false, we do something else. If milk equals 1, then we continue baking the cake. Else we abort and we don't make cake. Right there. You know, we make durian crepes instead, which I won't eat. Yeah. I'm sorry, durian is not my is not my fruit. That there. I tried it, but it's not that there. But again, an if-else statement is if something is true. I haven't started cooking dinner yet, so I go into the kitchen and I look and I see that I've got beef in the refrigerator, so I make something with beef. Else, I make something with chicken if I have chicken out there. Then we get into the else if structure right there. We'll see that in a minute. The switch is a multiple selection, which allows us to switch amongst a number of different things. So and we'll see that more in action. But that's where we have more than one choice right there. We may have 3 or 4 or 5, 6, 10 choices. If department, switch. Case, switch case, that there, department 22, something happened. If department 23, something happens. If department 24, something happens. Quite often we'll use this for pay grades or number of dependents when we calculate taxes or various things where we have multiple choices. So that there. So we'll look at switch statement. And then finally we'll look at iterations. We could almost stop this course on C after this chapter. This chapter covers 90% of the C structures that we're going to look at. We'll continue on because we'll get into functions and things like that. But programming, this is probably the most important chapter right there. So C only has 3 control statements, sequence, 3 types of a selection, that there, and 3 types of iteration. Iteration is we repeat. So for 1 equals 1 to 10, we do something 10 times. For each student in the class, we calculate their final grade. These things we do that there. So we look at there. So we have this whole idea of single there. So control statement flow chart goes here. I'm not going to read in that there. But we look into that there. I'm going to jump to the if. We've already talked about the if. I've used this example already. Of course, it doesn't hurt that I looked at these slides, half an hour to an hour before class, so I can anticipate the discussion. Some days I don't look at the slides ahead of time, and I get myself in trouble. That there, but that's just like some days you don't read your homework before a test, right? And you get yourself in trouble. That there. I'm giving a presentation, and I've got a set of notes called the slides provided by the Pearson Education Corporation. That they're written. They're not written by Dectal and Dectal. Some faculty member, provided their slides, and they've been, that they're. I've written sets of slides for textbooks before, so I know that the author usually doesn't write them. They're usually written by somebody else. But here we have the if statement. If the student grade is greater than or equal to 60, we print pass. Right there. So that goes back to what I was saying. That's the American system. We go on the 60, 90, 80, 70, 60 scale. So anything above a 90 is considered an A. Anything below Anything below a 60 is considered an F. Between 80 and 89.9 is considered a B. Between 70 and 79.9 is considered a C. Anything between 60 and 69.9 is considered a D. You know, that's a scale that I grew up with and I've used for decades. And it's a simple scale. I like the scale. You know, the Malaysian scale, I've yet to, even after, 3 years, I've yet to figure it out right there. And I probably won't. I'll probably retire before I figure it out right there. So, but if the condition is true, we're going to print pass right there. Remember pseudocode right there. If the condition is false, it's ignored. Now, that's the key thing about a single selection is that if the condition is false, nothing happens right there. So if the gentleman, Abraham proposes to the lady, then she has a choice to make, yes or no, right? But if he never proposes, then there's no choice. If he proposes, will you marry me? And the answer is no, then nothing happens, right? There's no wedding ceremony right there. But if she says yes, then a whole sequence of events occurs. And that's what the if statement is like. If the potential bride says yes, then of course the next statement might be is if the father agrees. That's always an important thing. In some cultures, in the U.S. cultures, it doesn't matter that there. So now when we write this, we typically like to indent our if statements to make things easier. So here's an example of the if statement. If grade is greater than or equal to 60, so remember we have the 6 conditions right there. Equal, not equal, equal than, greater than, less than or equal to, or greater than, or less than or equal to, less than or greater than. We have 6 conditions up there. So in this particular case, if the grade is greater than or equal to 60, we're going to print F passed. Now, in this particular case, nothing happens if the grade is less than 60. Right there. In a minute, you're going to see one where we say else print failed. Right there. So, that's it. So, if we look at our pseudocode, if student's grade is greater than or equal to 60, print student pass. Our pseudocode is a very long way of saying this. So as you get more experience with writing pseudocode, the translation process from the pseudocode to the actual C code is very easy. Now, that's true, especially if you're working in English, but it can also work if you're writing in Malay, Mandarin, Tamil, Russian, Chinese, or whatever, as long as your thought process, as when you write your pseudocode, follows the process of the computer language that you're writing in. And one of the things that I probably don't stress enough is the fact that computer programming languages may all look different. They may all feel a little different. Some are easier to learn than others. But they all do the same thing in the net result. If you're going to rebuild the engine on a BMW, it's similar to rebuilding the engine on a Proton. It may be easier to take the engine out of the Proton. BMWs are horrible cars to work on. I hate to say that. I've only owned one. My ex-wife owned a BMW once, and I hated that car. Fun car to drive when it worked right, but very fragile. And every time you took it to the shop, it seemed like all kinds of things went wrong when they tried repairing it right there. But regardless, all computer languages have a very similar flavor to them. Now, HDL languages, which are hardware description languages that look like computer languages, but they're used to design digital hardware, are not computer languages. They have a totally different feel, a totally different way of things going. They don't have the iteration type logic to them right there. I used to teach the basic digital course. Since then it was taken from me and I ended up with robotics instead. I always included a little section on VHDL or Verilog in there because that's the way people design digital circuits anymore. They don't sit off with Karnaugh maps and draw and or gates anymore. They design digital hardware by describing functionally what the hardware is supposed to do. That's the way I've done digital hardware for the last, I'd say 10, 15 years. I haven't used a Karnaugh map in many years, and I've designed a lot of digital circuits in the last 20 years. That seems to be more, I do more digital hardware design than I actually have programming in the last 10 years right there. So, but again, we're looking at there. Now, notice that we have a variable there. I can't write on here. Grade is our variable. It's an integer. It has to be defined somewhere else right there. The flow chart here shows what happens at there. And sometimes it's a little easier to see the flow chart. If grade is greater than 60, it's true. We print pass. Otherwise, we skip the print statement. We just totally skip it. I asked somebody, you want to go out for dinner? Are you hungry? Happens with my wife every now and then. I have a wife that sometimes just doesn't feel like eating. That's why she weighs 120 pounds and I weigh 240 pounds. I always feel like eating out there. But regardless, out there, what do you want for dinner? I'm not hungry. Well, that means she's skipping dinner right there. So, out there. But if she, are you hungry? Then the answer is yes, and we move on to our next set of instructions, which are, where do you want to eat? And unfortunately, her favorite restaurant is one called I Don't Know. That there. So, we eat at I Don't Know a lot, which actually turns out to be a little local Malay food stall that there, simply because it's the closest one to the house, essentially. But regardless, that's it. So the if selection has two lines emerging from it. Again, I'm not going to dwell on that. It's a single entry and a single exit statement. We go into it at the top, we exit at the bottom. So we either do that or we don't. Not there. So the if else statement is one that's a little different here. If a student's grade is greater than or equal to 60, we print pass, else we print fail. So now we have a choice right there. So one of two things happens. We either pass the student or we fail the student right there. So again, the code looks very, very straightforward here. Now notice here that I do have the bracket here and here. Remember what I said earlier, in this particular case, because we've only got one statement, in the if side of it, and one statement in the else side of it, the braces are not needed. But it's a good practice to include them. And also notice that we indent the print statement right there. The else statement falls right underneath the if, and we indent any statements that are in the else. We can also have as many statements as we want in the in the if side. And what's done here is what happens if this condition is true. We're going to print this. If this condition happens to be false, then we're going to do what's down here in the else part right there. So we have, this is the if else. Very commonly done that there. And here we show that with a triangle, and we have two choices right there. So, but there. Now, I'm just going to go through this slide. I do not use this syntax. I hate this syntax simply because it falls under that category of making your code very difficult to read. Right there. It's a shorthand syntax. A lot of younger programmers, especially those that did not take typing classes when they were younger. You know, one of my former lifetimes, I was in the military, and the military taught me one skill, and that was they sent me to typing school for about 3 months. You know, so I became a very proficient typist, and I typed a lot over the next 4 years. I was in the Air Force. You know, when people think of people being in the Air Force, you think about airplanes and that. I flew what we call a rack, a radio. That's what I flew, and I would hear things on the radio and I would type them. I'd hear things on the radio and I'd type. So I became very good at listening to Morse code on the radio and typing it. That there. So my typing skills prior to my stroke were extremely good. So I don't mind typing a lot. Right there. But this is a statement that looks like this right here. And this is a put string. And it looks at the condition grade greater than or equal to 60. If that's true, it's going to put the string pass. If it's false, it's going to put the string fail. Now, I look at this here, and this looks like cryptic garbage. Now, if you're familiar with C, and it doesn't look like cryptic garbage to me, but to you it should. You've never seen this syntax before. This looks very simple. You understand what's going on with this syntax right there. This actually is very, very straightforward. Now, before this lecture, you probably have not actually had to type one of these, or actually before the assignment I'm going to give you probably tomorrow or tonight, you probably haven't had to type the if that or the if else statement. I'm sorry, I keep putting the word then in there, the if else that there. But you look at that, and your first reaction as a non-programming person, a non-C programmer, is what in the heck does this do, right? That's the reason I don't like it. I understand why somebody would use this one line here to replace 6 lines here. I mean, because they do the same thing right there. It's just that when I'm debugging someone else's code and I'm trying to find problems in my code, I'd much rather look at the 6 lines that are clear to understand what's going on. You know, it's just like when I talk, I try to keep my vocabulary to what's called colloquial English, in other words. And I have to get away from colloquial English because I'm talking about computer programming, and not all the words in colloquial English are part of that vocabulary. But I sure don't use very large words that are obscure to the English language that only somebody with a PhD in computer science would understand. You know, I try to keep my language to something that most of you can follow me, if not on the first pass, maybe on the second pass, you know, listening to it, or after you read the book right there. The book tends to use larger language, more in-depth language than I do. But this statement right here, this put S, really falls under that category of it's really too cryptic for a non-C, experienced C programmer to understand what's going on. And I sure in the devil would not use it as a first programming class right there. So I would suggest that you don't use this type of syntax in your code, simply because it's too easy when you use syntax that's cryptic And the word, you know what I mean by the word cryptic, right? It's something that's in code that you don't understand. One of the things I did in the military was code breaking, so cryptology is a word that I'm very familiar with. But the word cryptology is very commonly known, is very well known today because banks have to, use cryptology to hide passwords and usernames and all that stuff. So, but this put S graded that's a very cryptic, hard to understand instruction right there. So again, he goes into this more detail right there. We can nest our if-else statements, and that's a very common thing to do. That there, where we have a whole bunch of if-else. That there. And here's an example here. And I gave this earlier. If a student's grade is greater than or equal to 90, we print an A. Else, if the grade is greater than 80, now a key thing here is that this second statement doesn't have to say is greater than or equal to 80 and less than 90, because if the grade is greater than 90, it would not get to this else right there. So we only have to look at that there. And if the grade ends up being greater than or equal to 60, we print D. Else, our default case right there is we print an F. So if none of these statements are true, the student gets an F. I mean, his grade has got to be something. Now, if it happens to be a 0 because he never showed up to class, and pardon using the word is all the time, but that there. But if a student's grade is 0 because they never showed up to class, never turned in an assignment, what grade do they receive? An F, right? If a student does extra work, which I don't have in this class, and gets 100 on all their tests, turns in all their homework out there, and does extra credit work, and ends up with a score of 112, that's okay, right? But now if somebody miskeyed a grade in there, and they end up with a grade over 100, and there's no extra credit, then of course we have to deal with that as an error. But there, we're not talking about error handling yet, right there. That's a later subject. Right there. So this is what that looks like. Now, I do not like the syntax very well because I don't like the way it angles off. I like to put them all under. Now, notice one thing here is that he left out the braces. He left the braces out in this particular case. Remember what I said before, that the braces were optional if you only had one statement in there. So in this particular case, they left the braces out. Now, normally you would put it this way. This is the way I prefer to indent this, because all these else's are equal in a sense, right there. So if grade is greater than or equal to 90, we put S. Oh, and we also kind of slipped a new command in there, and that's the put S, which actually is like they print F right there. It's included in that. So I just now realized that it was introduced back with that cryptic statement, so I kind of jumped over it. But the put S is a put string function call out there. So I still use the printf, but you can also use the put S right there. So else if grade is greater than or equal to 80, but we simply look at all the grade, and we decide what grade the student's going to get using this multiple selection if else right there. So as far as the C compiler is concerned, it doesn't matter that the latter is popular because it avoids deep indentation to the right. If you use this format, you're going to end up running out of room on the right-hand side of your screen if your statements get complicated. That's why I tend not to use it right there. So where this all keeps it in the same line. Plus, all these else's are equal to each other in terms of, we look at one, then we look at the other, we look at the other right there. Now, one thing I should point out here is that not all compilers like deep if-else structures like this. Right there. Dev C seems to do okay with it. Microsoft C seems to do okay with it, but I've used the Kyle C compiler for 8051s and ARM processors. That's for an embedded system. That's not a common compiler that you would use. And I've gotten into trouble where the compilers screw up these statements. The VHDL compiler that Altera puts out has got some problems with if you have too many if-else statements right there. It tends to break the compiler. So it's not something you should be concerned with at this stage, because the compiler you're working with will handle anything you give it. But if you had 20 of these in a row, then the compiler could really mess it up right there. This is about as complex as you'll get right there. Right there. Right there. And this slide points out, expects only one statement in the body. If you only have one statement, you don't need to include it in braces. I've been saying that there. If you include several statements, then you must use the braces right there. So a set of statements contained within a pair of braces, I usually refer to as a block right there. But he uses the term compound statement. That's been around for a while, but I just prefer a block of code. It's included in the braces right there. So again, this is right there. Here again, because we've got two statements in this else right here, you see where we got two statements there. Put S, you failed. Put S, you must take this course again. That's not something you want to see typically, right? Right there. Nobody likes retaking courses. Right there. So, right there. So, again, what they're saying is that if you don't have the braces, what happens here is if this brace is missing, this else is only going to print the first line as part of the else, and this put S, you must take this course again, will be printed each and every time. So the first half will work fine. If grade is greater than or equal to 60, it's going to print pass. Else, it's going to print failed. But because I don't have the braces, it's going to print, you must take this course again, whether the student passed it or failed it. That's not what you want. So the braces are very important in this case. Also notice that he does put some comments in here, end if and else. I don't always do that, but sometimes they really make troubleshooting a program easier because you know where these braces belong. One of the biggest problems that young programmers have, and older programmers too, we get forgetful, is what ending brace goes with what beginning brace. So his style is he puts the beginning brace at the end of the if line, and he puts the ending brace on a line by itself. I know some programmers will put the beginning brace under the if right there, and so the beginning and the ending braces are right above and below each other. So it all depends. Different programs. The compiler doesn't care. The compiler has no preference whatsoever. because it's going to eliminate all the carriage returns and blank spaces and lines anyway. So compiler doesn't care. So you can make your code as many pages as you want, but by adding lines and putting in carriage returns and keeping your lines short, or you can do all kinds of short cryptic command instructions right there. You know, actually, if you look at this statement right there and this statement right here, the compiler is going to act, you know, if you got a good compiler, it's going to create the same machine code no matter which way you write it. It doesn't care, because the compiler is designed to optimize your code to the shortest version possible. So even if you wrote this, which looks very long-winded and takes 6 lines, or you wrote this, which takes 1 line, the compiler is going to end up creating the same executable code for it. So my feeling is you're better off writing the longer version that's easier to understand and easier for your thought process to work with than trying to come up with all these short little tricks right there. I don't even, you know, to be honest with you, until I looked at this slide, I forgot all about using this syntax. I never used it. I don't use it. The reason I don't use it is because I don't know who's going to read my code 5 years from now, 3 years from now, and whether or not they can understand what this says right there. So, right there. The latter is more popular than that there. That just kind of talks in that there. We talked about this here. And then braces around is important. I just talked about that. There's 3 types of errors right there. A syntax error is one that's caught by the compiler. That's the most common error you're going to make first when you try to compile it, and it just won't compile. A logic error has its effect at execution time, and a fatal error is one that happens at execution time and causes the program to crash right there. The most dangerous of these types of errors is the logic error. A fatal logic error, the user at least knows something's wrong. It didn't work. You know, you used to get the blue screen of death with Windows 7, I think it was, or I don't know which version of Windows they did away with the blue screen of death, but then, you know, maybe it was 95. You know, now you get a little bit friendlier error messages that they're, but your program crashes and you know that the results from the program are garbage. But a logic error that adds a 0 to every employee's paycheck, you know, it goes ahead and prints out the paychecks and mails them out, or does the bank transfers to everybody's bank account, but instead of an employee getting 7,000 ringgits this month, you get 70,000 ringgits this month. That's a more dangerous error because the bank doesn't catch it. The employer doesn't catch it until their bank account ends up empty, right? That there. And those their logic errors cause all kinds of problems, can cause all kinds of problems. And those are usually done by programmers. You know, one of the most famous one was, and I can't remember whether it was the Mars, I think it was Mars, the NASA, which is the big space organization in the U.S., was sending a satellite or a landing module to Mars, and they were working with an international group of engineers and scientists, and the folks from the UK and France and Russia we're all using meters and kilometers, and those screwy programmers in the US are used to feet, inches, and miles. We're using different units, and guess what? The whole mission failed because the rocket went right by Mars, just kept on going right there. So there was an airplane crash in Canada a number of years back, and it came from the fact that the American pilot was thinking of how many pounds of fuel, that jet fuel, that they needed in the plane, and the person that was putting the fuel in the plane was thinking how many kilograms of fuel they needed. Now, here we had mixed units right there, and the program crashed. Now, the program itself was probably not bad. There was nothing wrong with the software, but because input was wrong in this particular case. But quite often logic errors occur and you don't catch them until later. Well, that's how airlines put sales on there where they sell airplane tickets from KL to Bali for 12 ringgits instead of 120 ringgits. You know, somewhere the software's got a little glitch in it right there. So the fatal logic error is still a logic error. Your program compiles, it works great, but your cell phone locks up, right? How many times have you had your hand phone lock up and you had to power down and power back up? You know, I've had a few of them where I've had to take the battery out, back when you could take batteries out and put the battery back in, you know, on some of the older phones. You know, those are fatal logic errors. It causes the hardware to flat out fail right there. So syntax errors are not a problem. You'll make lots of them. I make lots of them. I don't even worry about syntax when I type code. I basically type pseudocode, and then I hit the compile button, and I let the compiler catch my syntax errors. And I go back and fix it. So non-fatal error produces, you know, allows the program to continue, but to produce incorrect results right there. So that there, these are just, and getting into that there. All right, the while is the first of our iteration statements. Right there. And how am I on time? Right there. Oh, okay. I got some more time here. I'm going, since I'm declaring tomorrow a Skanda day, you know, rest and get caught up on my sleep again. I can't believe I slept 2 days in a row all day up there. But that's what happens when you're recovering from something. But an iteration is you repeat the same operation over and over and over again. Now, if you're working in a factory, and I've had some really crappy jobs in my life, including one where my job was to clean chicken manure from underneath chicken cages. I can call that a really crappy job right there, literally, because I came home every day smelling like chicken manure out there. So at least my wife at the time thought it was a crappy job. I wasn't allowed to in the house, you know, with my work clothes. But you know, I had a job for a short while where my job was to reach over onto a cart, pick up a magnetic core, only was magnetized yet, an iron core for a speaker, and put it on speakers as it went by the assembly line. And that was my job, you know, total job. So while not end of shift, move speaker cores to speaker right there. That was essentially what I did. Until break time, till lunchtime, which time I clocked out for lunch and never went back, because that was probably the most boring job on the planet. That there, and you know, and some of you have had, you know, feel that you probably have had some boring jobs in life. This was back before headphones and you could listen to music, and before iPhones where you could sit there and play with your phone while you're moving back. You literally just stood there and stared in space and picked up that there. So it was a very boring job that there. But again, pseudocode, while there are more items on my shopping list, purchase next item and cross it off list. Now, of course, I don't use the shopping list, but my wife seems to always have a shopping list in her head because we'll go to Eon and she's always got a list of things she wants to buy, but it's not on paper. Not there. And then she gets home and then realizes she forgot something because it should have been on paper. I mean, she's also 61 years old, so now she forgets a few things too. So I'm nothing wrong with my wife. I mean, just as you get older, you tend to forget a few things here and there. So it's not dementia or Alzheimer's. That there, the old joke is if you lose your car keys as you get older, that's normal. When you find your car keys and you forget what they're for, then you probably got dementia. That there, so that there. So far she loses her. Well, we don't lose the car keys. We've learned to put them in the same spot, but the shopping list. But you keep repeating the same process until you finish the job. While not end of students, I call a function to calculate course grade, where I go through and read each of the exams and I calculate that. So the condition is there are more items on my shopping list. So that's a true or false condition. While not end of students. In other words, I have not reached the end of my list of students right there. So while not end of shift right there, or not break time or whatever right there. So we repeat this repeatedly until as long as the condition comes true. Now there are some while loops in the embedded world that we run forever out there. In other words, we may have a while one in there. I used to declare a variable, hell freezes over and sets it equal to 0, and I will put while not hell frozen over, in there. So in other words, so the software for your gasoline petrol pump, you probably want to continuously run that until you turn the pump off, right? You don't want it to go through one iteration of processing one customer and then quit. You wait for the next customer to come and you say insert card and pump petrol. It may reach a point that you're going to print out the daily totals as part of the software. Then you shut the computer down if it's not a 24-hour pump. So there are while loops that are forever. Normally in this class in desktop programming, all of our while loops should terminate. They should end right there. And for whatever reason, it's ignoring my keyboard. So that there, while may be a single statement or compound. Normally whiles we put a block of code. We include the braces. So the same rules apply with the while as it does the if and the if else. So if it's one line of code, we don't need the braces. If it's more than one line of code, and it normally is with a while, we're going to use the braces right there. So eventually the condition becomes false. I've purchased everything on the shopping list, and I can move on to the next part of my code, which would be push cart to cashier and wait for 20 hours for empty cashier, right? If it's the day after payday and you're going to Eon or Eon Big, you'll wait a while at the cash register. But regardless, that the iteration terminates in the first statement after the iteration is executed. So that hopefully we'll end this here. Here's and he does it to us again. He introduces a new, no, he doesn't. Okay, that's there. He says product is equal to 3. He says, well, product is less than or equal to 100. Product equals 3 times the product, and we end the while. So we keep doing this. Now, I have a bit of a warning here, and this is, if you put this in your code, the compiler may just take it out. And the reason the compiler might just take it out is that this while loop doesn't produce any output or change any variables other than product. And if product is not used anywhere else, the compiler may make a decision that this code just wastes time and just take it away, just disappear it right there. So we don't know what the rest of that there, but what they're trying to show is here we have while product is less than or equal to 100. Every time we go through this loop, we're multiplying product times 3. So the first time through the loop, product is going to be 3. Then it's going to be 9. Then it's going to be 27. Then it's going to be 3 times 27 is what, 86, something like that. That there. Then it's going to be 240 something. When it reaches 240 something, it's going to not enter the loop. It's going to just skip the loop. So this will probably only execute 3 or 4 times right there. So, right there. But again, it goes through Odyssey. That's there. But here we're saying product is less than or equal to now this looks a little bit like the if statement, but notice what's different here is that the arrow goes back to the top. And it just keeps repeating this same line of code over and over again until this is no longer true. Right there. Now we also have the do until statement, which is covered later, that is very much like the while, only we put the condition at the end of the loop right there. So this just kind of goes through here, and it goes. My math is wrong. It's 9, 27, 81, and then it goes to 243 where it drops out. For whatever reason, I got up to. I can't multiply today. So consider the statement. Took a quiz, integrates, determine the class average. Again, here we're using a counter. And the counter is we know exactly how many students there are. In this particular case, we have 10 students. And we can use the while grade counter is less than or equal to 10, input the next grade, add the grade to the total, add 1 to the grade counter, and then we calculate the grade. And our code's going to look like that right there. Now, I'm going to kind of stop here at this point here. Notice that right here is that we have to increment our counter within the loop. If we don't increment our counter within the loop, this loop will run forever. That's a common mistake that people will make, is they'll keep running this counter over and over, and because they forget to increment that there. Now later, probably next week, we'll introduce the for statement right there where we don't have to do that. And again, this just shows a run of this particular program right there. So here, I think let me see my time. An hour and 10 minutes is about my limit. We're pushing my limit right there. So I think I'm going to stop at this point here. So I don't know, our class is scheduled to be what, an hour and 30 minutes or an hour and 50, something like that. Hour and 50 minutes? Hour and 15 minutes? Okay, well, it says 2 hours on the schedule, but I I know that nobody ever runs a class 2 hours. I've never run classes much beyond an hour, and this is probably close to one of my longer ones. So I'm going to stop here, but we're